So I'm going to find the greatest common factor. I'm going to do three different things. And the first thing I'm going to do is I'm going to find numerically. And all you have to do is, if you want to find the greatest common factor, what you have to know what the factor is. When we have two numbers, 3 times 7, it equals 21. And so 3 and 7 are factors of 21. They're two numbers that multiply to 21. It's a little bit different though, because if you had a number like 36, you get to 36 by saying 1 times 36, or you could say 2 times 18, or 3 times 12, 4 times 9, or 6 times 6. All of these are factors of 36. So if I had, let's say, I had 36 and I had 24. Now, I personally like to do things like this. I say 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24. And the reason why is because I'm going in order. 1, 2, 3, 4. I'm finding their counterparts. No, their corresponding factors. But then when I get to 5, there is no factor that goes into 5 doesn't go into 24 evenly. I get to 6, but I've already have 6, so I know that I have all my pairs. If you end up with an odd number, you mess something up. So once I do that, I like to just write these out. 1, 2, 3, 4, 6. I don't have to write 6 twice because really once is enough. So you should have an odd number there because 6 is repeated. Then here I'm going to write 1, 2, 3, 4, 6, 8, 12, and 24. Now 1 is a factor, and 2 is a common factor, and 3 are common factors, as are 4 and 6. But the greatest common factor, the number that goes into both evenly, the greatest number is 12. So the greatest common factor of 36 and 24 is 12. I'm going to show you two more examples. I'm going to say 8 and 10. Well, these ones are pretty easy because 8 is a very easy number to do, and 10 is an easy number to do. And sure enough, it's 2. It is always possible to have something like this. Let's say you had, let's say 10 and 17. Well, 10 is 1, 2, and 5, and 17 is 1. No, that's not even true. I don't know why I just wrote that. It's 1 and 17. So their greatest factor is 1. That's because 17 is a prime number. Alright, so I hope that makes sense. Now I'm going to erase this stuff now. If you need to pause or rewind or do any of that, that's perfectly fine. Go right ahead. Do so. I'm going to make a couple videos, so that's okay. I'm not going to do algebraically because that's not what I want to do. I'm going to do how do we find the greatest common factor of variables? Well, what you need to remember is x equals x. And that's obvious. But x squared equals x times x, and x cubed equals x times x times x. So if I had two variables, let's say I had x squared and I had x to the fourth, this is really x times x, and this is really x times x times x times x. So how much do they have in common? Well, they both have this in common, which is x times x is x squared. So the greatest common factor of x squared and x to the fourth is x squared. So now, and the true thing is, whenever you have a common variable, common base, it's always going to be the smallest power. So if I wanted to find the greatest common factor of, I'm going to do 3 terms. Let's say I had 10a squared b. Let's say I had 25ab squared, and let's say I had 50a squared b squared. All right. Well, my factors would be 1, 2, 5, 10, a, b. Here it's 1, 5. I don't need to write 5 twice. 25, a, b, and b. Here it's 1, 2, 5, 25, 50, A, B, B. And the reason why I'm writing the A's and B's more than once is I'm going to illustrate that in a second. But you can see we don't care if it's 1, really. This has a 2 and this has a 2, but this doesn't, so the 2's are no good. I have a 5, and a 5, so here this looks promising. Here I have 10, 25, and 25, but because these two have 25 but this one doesn't, these are no good. So it's going to be, and none of them have 50, so except for that one. Here I have A and A, but here I don't have two A's, so one A will work. And here I have B, B, and here I have B, B, but only one B will work. So my common factor of those three is 5, A, B. Alright, hope that helped. Hope this records.